Okay, so welcome. In this example, I'm going to look at this fraction and we're going to create two equivalent fractions. Okay, so let's take this fraction. If I multiply the top and the bottom by 2, what is that going to give me? So if I multiply the top and the bottom by 2, notice that I'm basically multiplying by a form of 1, right? So if you think about it, if I multiply any number by 1, I get the same number. So intuitively, we know that the resulting fraction is going to be the same thing that we started with. Because all I'm doing is using the property of multiplying fractions. And so if I multiply across the top, I get 12. And if I multiply across the bottom, I get 16. And the fact that I multiplied by 1 tells me that these two are equivalent. Now, what if I divide the bottom and top of this by 2? So I divide the top by 2, that's going to give me 3. And if I divide the bottom by 2, that gives me 4. And so that gives me 3/4. So by the fundamental principle of fractions, 3/4 is equal to 6/8, which is equal to 12/16. Now, can I do the same thing or have the same reasoning that I did up here with this one, with the division by 2? Absolutely. So think about this. 6/8, and now I want to divide both the top and the bottom by 2. But isn't that the same as multiplying the top and the bottom by 1/2? Isn't that also a form of 1? Sure. And so what happens? This equals, if I multiply across the top, I get 6 divided by 2. And if I multiply across the bottom, I get 8 divided by 2, which gives me 3/4. Okay? So that's another way to look at this principle. Okay? All I'm really doing is multiplying any fraction by a form of 1. And as you can see, I have an infinite number of equivalent fractions. There are an infinite number of equivalent fractions because I can keep going with as many different numbers as I can think of, which there are infinite. Okay? And notice that also, listen, that equivalent fractions are always a multiple of one another. So that's another key takeaway, is that to be an equivalent fraction, one must be a multiple of the other. Okay? That multiple might be a fraction, but nonetheless a multiple. Okay? See you next time.